Good afternoon, students.
Good afternoon.
All right. So we're going to be looking at physics practical, and we're going to be looking at a very simple topic: the simple pendulum. Now, if we are carrying out a practical on the simple pendulum, there are some apparatus, or call it some materials we need. All right. Now, as you can see, we have the apparatus on the board. Now we have the pendulum bulb. Now this is the pendulum bulb. For those of you that don't know what pendulum bulb is, this is called a pendulum bulb. They are of different size, but this is what we're going to be using for today. So we have a pendulum bulb. Now we have a clamp. We have a retort stand. Now this is a retort stand. Alright. This is a retort stand. We also have the thread. Now this is your thread. Now thread is a very common thing. Now this is your thread. This is the thread we are using. Alright. Now we also have a stopwatch. Now the stopwatch tells us the time, and this is a stopwatch. This very one, they are different type, but this is the one we are using. All right, this is a stopwatch. We also have a meter rule. This is your meter rule. It's 100 centimeter. That's the standard meter rule for physics practical. All right. Now let's see. Now, if you want to carry out a physics experiment, so what you need to do, you look at the diagram and follow it step by step. Don't jump anything. So first of all, you look at the diagram, you read the question so you know what to do. Now if you see, this is setup of the experiment. Now as you can see, this is the retort stand, which is this. Now this is your pendulum bulb. Pendulum what? Bulb. Now this is the length of the thread. It means from this place to this place is the length of the thread. That's why it is called what? L, which is the length of the thread. Now, what this thing is trying to show you that it means you have to displace your pendulum bulb to an angle. Now, the angle was not specified, but if you are carrying it out, you just displace it to a very small angle. Then you leave it. Then it is left to what? To oscillate. Alright? That's oscillation. Now, let's see. Now, we have our bulb. We have our thread. Now, let's see. Let's read what we have there. It said, set up a pendulum of length 100 centimeter. What they are trying to say is that the length of the thread should be 100 centimeter. Now if you see what I've done here, now this is your pendulum bulb which you have here. Now this is the length. That's the first thing they ask us to do. The length of this thread is what? 100 centimeter. That's the first thing they asked us to do. They said of length 100 centimeter, which we have done here, 100 centimeter. Alright. They said find the time t for 20 complete oscillation. Oscillation means I have to set it to an angle, alright, to a small angle, then I leave it. Alright, they said for 20 complete oscillation, it means I have to count 20 times. If it goes and comes, that's one oscillation. Goes and comes, that's two oscillations. Since they said 20, I have to do it for 20 times. And I will use my stopwatch to know the time. Alright, as soon as I leave my pendulum bulb, I'll start my time and I'll start counting till it gets to 20 oscillations. Then my time, I'll record it. Now if you see what I have here, it said for 20 complete oscillation, repeat the experiment for L equals 80. It means after doing 100, the next thing you do is what? 80. When the length is 80, when the length is 60, when the length is 50, when the length is 40, and when the length is what? 30. They said tabulate your reading. It means put your readings in a tabular form. And that's what we have here. Alright, let's see. Now we have these lengths 100, 80, 60, 50, 30. And this is T1. And this is T2. Now the reason why we are doing it T1 and T2 is to make sure that there is no error. Alright? So it means you carry it out the first time, you do it again, then you get the average. Simply means what? Average. It means it's going to be this plus this divided by 2. That's what you get here. That's to make sure that there is no error, to eliminate error. Alright? Now, for the period is simply your what? Your time divided by n. Your n is what? Number of oscillation, which is what? 20. So anytime you get here, you divide it by 20. That's what's going to be here. Alright? Then also, you square your period. That's what you have here. You square it and you get what's here. Alright? Now they said plot the graph of L against T squared. This is L against T squared. It means L will be in your vertical as this, L in centimeter, and your T square will be what? Here. So this is the graph you are going to plot. Your L against your what? Against your T squared. Alright? So let's see. So let's start from the very first one. L to be what? 100 centimeter. So what I'll do is this now. The length I have here is 100 centimeter. Alright, so I want to know the time. So I will displace it. To an angle, to a small angle. The angle was not specified, so I will displace it to a very small angle, right? And see what it's going to give me. So let's see. Let's displace it and see. I said 20 complete oscillations, so we have to go around 20 times. Is it not? Alright, so let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if you see what we have 40.53 seconds. The time is in seconds. 40.53 seconds. So we record it in the place we have T1. 40.53. Okay. Now what we do for the T2, we do it again and see if there's going to be difference between the two of them. So we do for 100 again and see if there's going to be difference between them. If there is difference, we take the average and put it there. Alright, so let's go again for 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So let's see what we have. Now if you see what we have now, we have 40.19. Now 40.19, you see there's a difference between what we have now and what we have before. So we are going to put 40.19. There's a difference. So what do we do to get the average? It's going to be this plus this divided by 2. And if you add this and this divided by 2, so what will you get? When you add this and this divided by 2, 40.36. Now you see what we just did now. To make sure there's no error, we just did this plus this, then we divide by 2. Gives us this. So from there we can actually get a period. It's just what I have here divided by what? N. And our oscillation is 20. So what we do is this. 40.36 divided by 20. 2.01. That will give you 2.01. To get T squared, I square this value. And if I square 2.01, I'll get 4.07. So you see I'll fit the whole part for 100 centimeter. So it's not left for us to go towards 80 centimeter. Good.
Now let's go.
Alright. Now we are through with 100, the 100 centimeter. You see we have filled everything. So it's not left for us to do 80, 60 and the rest of them. So let me call up some students to come and complete the rest for us. Okay? Alright, Peter, come. You come.
As a parent, I have always asked, how can I prepare my children for the infrastructural development and socio-economic evolution of the next decade? With the ongoing speed of globalization, how can I position my children to perform excellently in a rapidly changing society? The answer is and has always been to give them a solid foundation. Academically, spiritually, and morally. Salvation International Preparatory Schools, with her team of highly qualified tutors, conducive environment for learning, state-of-the-art computer and science laboratories coupled with quality day and boarding facilities, is the place to be. For more information, contact 080-233-76135. SIPS remains the birthplace of leaders.
Now I want to continue from where our teacher stopped. We want to do 80, 60, 50 and 30 centimeters. Now I'm going to measure the rope to see if it's 80 centimeters. She's going to be with the stopwatch. Now the rope is at 80 centimeters. We can start the experiment. Stopwatch ready. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now the time was 35.73. Now we're going to do it again to get T2. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 35.7. Now we're going to add these two together to divide by 2 to get the value of T. 35.74. Now we're going to get the period. The period is T divided by the number of revolution, which is 20.
1.78.
Now we're going to find T square. Whereby we're going to square this and get our answer.
3.19.
3.19.
Salvation International Preparatory School. Salvation International Preparatory School. A place